friends, today in this class we are going to discuss about this Bohr's model of an atom. Okay, so in the past history we can see that before the discovery of the atom or atomic model, there is contribution of number of scientists for the model of an atom. So in this category we can see that the very first model was proposed by J.J. Thomson, which was discarded, and later on after him the model was given by Rutherford. Okay, so Rutherford has performed a gold foil experiment, and he also told about the model of an atom. And after him, so Bohr was the scientist who gave his model for an atom. So here we are going to discuss in this class about the postulates given by the Bohr for the model of an atom. Okay, so according to Bohr's first postulate, we are going to see he told that the total amount of charge, total positive charge of the entire atom is concentrated in a very small space, which is called nuclei. Okay, and the negatively charged electrons revolve around this nuclei in circular orbits. So let us see, this is the first Bohr's orbit. Bohr's first postulate. So this is first postulate. So according to Bohr, if this is the nuclei, let us see this is a charge Z. Now the electrons revolves around the nucleus in circular orbits. So this is one of the electron. It is moving like this with velocity v. So according to this statement, we can see that the entire positive charge of the atom is concentrated in a very small space, which is called nucleus, and the electrons revolves in this around this nucleus in circular orbits, where the necessary centripetal force is provided by the electrostatic force of attraction between the nucleus and the electron. So the formula for this first postulate becomes, this is centripetal force mv square upon r is equal to, this is k Z square by r square. Okay, so this very force is centripetal force, and this is the electrostatic force, which we have already studied in the electrostatics. Now as far as the force between this nuclei and the electron is concerned, it is always towards the center of the circle or towards the nuclei, and the centripetal force acts on the electron in the tangential direction. Okay, so this is about the first postulate. Second postulate, when we talk about the second postulate, so let us see second postulate. So in this postulate, he told that the negatively charged electrons revolves around the nucleus in some discrete orbits or in some specific orbits where no energy is radiated. So electrons always revolves around the nucleus in some discrete orbits, not everywhere, only in specific orbits where they do not radiate any energy. Okay, and in this case, according to this second postulate, we can say that the angular momentum of the electrons is always equal to nh upon 2 pi. So the second postulate, the formula for the second postulate comes to be, this is angular momentum of the revolving electron is equal to nh upon 2 pi. So from here the quantum theory was introduced. This is our principal quantum number. As you have all studied in chemistry, n is principal quantum number. It denotes the number of cells or the number of orbits around the nuclei. Okay, the value of n may be 1, 2, 3, 4 like this. H is Planck's constant, and this is the angular momentum. It is basically mass of the electron, and this is velocity of electron, and this is radius of orbit. So in the figure we can see that this the distance from the center to the electron is radius of the orbit. Right? So friends, this is the second postulate, Bohr's postulate. Okay. Now we are talking about the third postulate. So this is third postulate. So according to Bohr, whenever the electron jumps from high energy levels to the low energy levels, then they radiate some energy. Okay, and the energy radiated is given by, this is E2 minus E1 is equal to h nu. Okay, so this is third postulate. Here we can say this is the energy of the higher orbit and this is the energy of lower orbit, and it is Planck's constant and frequency of light. Okay, so according to this Bohr's model of an atom, he clarified these points, and this later on became the Bohr's theory or Bohr's model of an atom. But Bohr's theory even also is applicable only for small atoms, or say hydrogen atoms or hydrogen-like atoms. Okay, so let us see. We are going to find out the formulas for velocity of electrons, then radius of electrons, then frequency of electrons, and the total energy associated with the revolving electrons in the Bohr's orbits. Okay, so let us see. I am going to tell you all the formulas. So just I am going to rub it. Now friends, as we know, the electrons are revolving around the nucleus in circular orbits. Okay, so there will be some velocity of the electrons. So let us see this very first formula. This is velocity of electrons. So as far as velocity is concerned, we are going to find out the formula for velocity of electrons independent of radius of the orbits, because as the orbits will increase, the radius will also increase. So we will use first two postulates. So let us see. We can see that mvr is equal to nh upon 2 pi, and the second is, this is mv square upon r is equal to ze square kze square upon r square. Okay, so in this case we have written two postulates, or the formulas of the two postulates. With the help of both the formulas, we are going to find out the formula for velocity of the revolving electrons. Okay, so from very first we will find the value of radius, and we will put the value of r in this second formula, and ultimately we will get the formula for velocity of electrons. So let us see. From first, r is equal to, this is nh upon 2 pi, this is mv, right? And in this formula we can say, if we cancel r and r, we will get mv square is equal to kze square upon r. So we will put the value of r here. So this formula will become, this is mv square is equal to kze square by, in place of r we have to put this value, so it will be nh into 2 pi mv. Okay, now here we can cancel out the velocity, and mass is also cancelled. So finally formula for velocity becomes, this is 2k ze square, and it is 2 pi k z square upon nh. So finally we get the formula for velocity of revolving electrons. In this formula you all can see that 2 pi, this 2 pi is a constant quantity, k is also a constant quantity. It is 1 upon 4 pi epsilon naught, which is equal to 9 into 10 to the power 9. Z is atomic number, and E is charge of electron, which is already known to us, and H is also a constant. Hence we can say, as the number of this quantum number increases, the velocity will go on decreasing. So we can say here, velocity of revolving electron is inversely proportional to principal quantum number. So in the outer orbits, as we go in successive orbits or outer orbits, the velocity of electrons goes on decreasing, right? So this was the formula for velocity. Now we are going to find the formula for radius of the revolving electrons. So let us see. So this is radius of. So in the short, I am writing here in the short, but this is not the radius of the electrons. It is basically the radius of Bohr's orbits in which the electrons are orbiting, right? So let us see how we will find the radius. Now, because in the before expression we have seen that R is equal to, so this was mvr is equal to nh upon 2 pi, like this. So R was equal to, we can say this is nh upon, this is 2 pi mv. Okay, so now what we will do, we will put the value of this v in this expression. So putting the value of v, we will get here nh upon, this is 2 pi m, and here we will get 2 pi k ze square upon nh. Okay friends, so now this is the formula for radius, and finally we can write it like this. So it will become R is equal to n square h square upon, this is 4 pi square, this is k z e square m, like this. Okay, so let us see, this is 4 pi square and this is k, then z e square m. So final formula for Bohr's radius is this. So this, from this formula, you all my friends, you can see that now again all the quantities are constants. So for hydrogen or hydrogen like atoms, everything is constant excepting principal quantum number. So as the quantum number increases, the radius of Bohr's orbit also increases. So we can say here the radius is proportional to n square. Okay, this is very important fact that you should remember here, right? Okay, now we are going to see to find out the formula for frequency of revolving electrons. So let us see, this is the formula for frequency of revolving electrons. This is third one, frequency for revolving electrons. Now, what we understand by frequency means per second how many revolutions an electron can do or perform in a particular orbit. So let us see, as we have seen, the formula for velocity was v is equal to, this was 2 pi k z square upon nh. Okay friends, now as we know velocity v is equal to r omega, so we can say that because v is equal to r omega, where omega is angular velocity. Okay, so also we know that omega is equal to 2 pi nu, so we can write it, this is r into 2 pi nu. So nu is frequency here, frequency of the revolving electron. So we will put the value of v, this one here, and finally we will calculate the formula for frequency. So this is 2 pi nu into r, and it is 2 pi k ze square by nh, right? So 2 pi is cancelled now, so frequency becomes nu is equal to, this is k ze square and it is nhr. So I have given the formula, the frequency of revolving electron is k ze square upon nhr. Okay, so here we have seen the three formulas of these revolving electrons. Now further, in the last, the very important article is the total energy of the revolving electrons. So let us see. So we are going to find out the total energy of revolving electrons in Bohr's orbit. This is total energy of revolving electrons. So my friends, first of all I want to tell you that a revolving electron in the Bohr orbit, when an electron revolves in the Bohr orbit, it possesses both the energies. It possesses kinetic energy as well as potential energy. Okay, so let us see how we will find out the formula for both the energies. So here we can say now the kinetic energy of the electron. So let us see, this is kinetic energy. So because kinetic energy can be written as half mv square like this, but according to the first postulate we have seen that mv square upon r is equal to k z is square upon r square. So we can say that if r is cancelled, so the value of mv square is equal to kz e square upon r. So putting the value of mv square here, so kinetic energy will be finally, this is half, this is k z e square upon this is r. So here we can write this. The finally expression we can write it, kinetic energy is equal to k z e square by 2r. Okay? Okay. Now here we can see that in this expression the kinetic energy of the revolving electron is totally positive. It is always positive because the mass of the electron cannot be, and mass of any object cannot be, never be negative, and the velocity is a square quantity here, so that's why the kinetic energy is positive. Now here comes about the potential energy. So potential energy of the electron can be calculated by PE. This is equal to, we can write it K ZE, and this comes to be minus E upon R. Here I want to clear that the energy, because energy is a scalar quantity. Now as we have seen the formula in electrostatics, U is equal to, this is Q1 Q2 oblique 4 pi epsilon naught R. So by this formula, so here we are having two charges, Q1 and Q2. So one charge is ZE, which is positive charge inside the nuclei, and the second charge is negative electron. This is minus E. So we have put the charge, value of charge is ZE into minus E, and K is 1 upon 4 pi epsilon naught, and here comes the R. So is it clear? So the finally formula for potential energy will be PE is equal to, this is minus K ZE square upon R. So this can be written as like this. So from these two figures we can see that the kinetic energy is positive and the potential energy is negative. Okay. Now the potential energy is twice of the kinetic energy because there is 2 in this expression, right? So now we are going to find out the total energy of the revolving electron. So let us see total energy. So this will be, we will add kinetic energy as well as potential energy here. So the total energy is equal to, we can write it kinetic energy plus potential energy, and this is K Z E square upon 2R, and this is minus K Z E square upon R, and finally it becomes total energy is equal to, this is minus K Z E square upon 2R. So friends, finally you can see that the total energy of the revolving electron is in minus, and it is its magnitude is always equal to the magnitude of kinetic energy, but total energy and the kinetic energy are half of the energy, potential energy, Okay, this is also final from all the three expressions. Now, as we have seen that r is equal to Bohr's, the radius of the Bohr's orbit was, this is n square h square oblique 4 pi square k square z square e to the power 4m. So this was the value of Bohr's radius. So putting the value of r here, if we put the value of r, the energy, total energy will become, now we are going to put the value of r here. So this will become yeah, this was 4 pi square k z e square m, like this, 4 pi k z e square m. So we are putting here, this is it will become minus k z e square upon 2 into, this is n square h square upon 4 pi square k z e square m, like this. Okay, then the final formula will be, this is again E is equal to minus it becomes 4 pi, sorry, this will be cancelled, it will become 2. So this is, let us see, E is equal to, now from this expression we can write this, A is equal to 2 pi square, this is k square, then it comes to be z square e to the power 4 m by, this is n square h square. From this expression, and this is minus also, negative. So from here we can see that all the quantities, most of the quantities is 2 pi square k square e m h. These are constants excepting z and principal quantum number. So when we put the values of these quantities, the value, calculated value becomes, the calculated value becomes A is equal to, this is minus 13.6, this is z square upon n square, and for hydrogen atoms z is equal to 1. So finally the total energy becomes, this is equal to minus 13.6 upon n square electron volts. So by this formula we can calculate the energies of various orbits which are associated with the revolving electrons in Bohr's orbit. Okay, so on the basis of this, the spectral series of hydrogen atoms were described later on by our scientists and Bohr, and thus it is the final formula. And for other atoms, the science is still now doing research. So it was all about the Bohr's theory of an atom. So in this particular class, I have told you about the Bohr's postulates and Bohr's theory, and finally we are studying the model of an atom on the basis of Bohr's theory now. And for viewing our further videos, you can subscribe our YouTube channel. Thanks a lot.